All right, so now we've got a little bit more financial math, part two, video part two. So now we're going to start looking at a different type of calculation. So we're going to look at inflation and depreciation. Again, I have the some of the definitions already laid out here. These are the so inflation is the increase in cost over of an item over time. Index is the projected cost of an item in the future based on some average or some inflation rate or some inflation value. Your purchasing power is what you can buy with your money today. Your real value is what an investment would be worth today, your purchasing power today, based on the indexed value in the of the investment in the future. So the real value is says, hey, what would this thing be? What, like maybe a painting. I think we've got an example in here where we're doing a painting. So what would the value of this painting be today or in today's dollars based on inflation? So we're going to project out, we're going to inject, we're going to index, we're going to project out what the cost of that thing will be worth or the value of that thing will be worth. And then we're going to look at it based on today's money. So we can kind of say, oh, okay, if I had this much today, then I could, I could buy that thing in the future because we don't know what the actual interest rates or the actual inflation rates will be. And then depreciation is just the loss of value over time. So let's put some of these things into effect and see what we can come up with as far as our calculations go. And these aren't very complex. The complexity of these types of questions are really understanding what's happening up here. That's what a lot of this kind of upper level math is really. Do I understand what I'm doing? Because the computations are going to be pretty straightforward, or you're going to be using your calculator. Okay, so Georgia is going to purchase a painting that is currently worth $5,000. She makes monthly deposits into an investment account so she can purchase it in 3 years' time. So she knows, or she's predicting that the inflation is going to be 2.5% per year. So that means her the inflation means the cost of this thing is going to go up. So she wants to know what is the value of the painting when you consider the cost of inflation. So we need to think about, okay, so what we're trying to do is we're trying to say, what is this thing going to be worth in the future based on this inflation, or how much will this thing cost? So really, if she says, all right, there's this thing that's $5,000, I want to buy it, but I can't buy it right now. So I'm going to be paying this off. I'm going to purchase this, or maybe I'm going to do something. I'm going to find some way to buy it. So because I know inflation happens, or because Georgia knows inflation happens, she knows it's not going to be $5,000 in a few years. So she's got to have an estimate of how much does she actually have to save. So in 3 years, she knows how much this thing is worth. That's roughly what's going on here. All right, so let's calculate this. So the index value. So we're gonna find the indexed value here. So the indexed value is going to be equal to. It's going to be equal to the initial cost. So I guess you could say u of 0 times the inflation rate 1.025. Actually, let's do this. Let's say let's maybe we can make it the inflation rate. Inflation rate. Maybe we call that I again, times the inflation rate to the number of periods. So it's actually kind of very similar to what we did before, times I to the nth power. Okay, so n here, n is going to be 3 years. I is going to be 1.025 because it's 2.5%. And again, we're going to be applying it to the balance of 5,000. And u of 0, the initial value is 5,000. So here we can do 5,000. So the index value is simply 5,000 times 1.025 to the nth power, or not to the nth power, to the third power. All right, and that gives us a value of $5,384.45, maybe, right about in there. So that's what the indexed value of this painting is. All right, so let's look at another one, shall we? We're going to run through a bunch of these. Again, it might be a long video, but we're going to try and get through a good handful of questions here. So Gemma invested $4,000 in an account for 5 years at 4.8% per annum interest, compounded half yearly. Inflation over that time is 3%. Wow, that's a lot. So, I mean, that's a lot of information right there. Calculate the value after 5 years and find the real value of this thing. All right, so first thing we need to do is we need to think about compounding this thing half yearly. So here we know that this thing, if we kind of use the colors that we used up above or in the previous video, the I for calculating the compound interest is 0.048 divided by 2, because this is saying this is happening per year, and we're doing it 2 times per year. So that will give us a value of 0.024. So that's our compounding interest, but we're doing that for 5 years. So in this case, our period n, remember that's our period, or the number of times we're going to compound, and that's going to equal 10. And then u of 0 is 4,000. So here is our u of 0, our principal, our initial amount, or what we call u of 0. So u of 0 equals 4,000. All right, so first thing what we're going to do is we're going to calculate what the investment is over the 5 years. Okay, so we're not even worried about the inflation yet, because we're just going to calculate what this is over 5 years, and that's using all of this information right here. So if you remember, we had for A, we had an equation in the previous video that said u of n equaled u of 0 times 1 plus I to the nth power. So now we've got all of that information right here. We can substitute that in, that u of, what are we doing? U of 10. U of 10 is equal to 4,000 times 1.024 to the 10th power. All right, and when we calculate that out, we get $5,070.60. Okay, so that is our value of investment. Value of investment after 5 years. And so then B says find the real value. So if we go back up here and we look at the real value is what an investment would be worth today based on the indexed value. So what we need to do is we need to find the real value now. And so the real value is equal to, the investment is 5,000, let me back up a second. The investment is worth 5,070. We want to work backwards to find out what is the value today based on this. Okay, that's what the real value is. What is it based on today? How much would it cost me today for this investment in the future based on all of this stuff? So to get that, we're going to take this is the way the book does it, but we're just going to kind of do a quick computation. So the real value, so if we think about the real value, if we're indexing it, we take the value and we multiply it by the inflation rate, right? So that's 1.03. So we would take the real value and we would multiply that by 1.03, the indexed value. This is the index. All right, just like we did up here. So we multiply it by the index. And then that will give us the value that we just calculated, 5,070.6. So we want to know what would this be if this were the inflation or the index rate to get to this. So how much does it cost today? So how much is this investment worth today if we know that it's going to go up by this amount and come out to that? So to calculate this, all we're going to do is we're going to divide both sides by 1.03, and that's actually to the fifth power, right? Because we're going 5 years, so 1.03 to the fifth power, and we're going to divide that on both sides. So our real value then, is equal to 5070.60 divided by 1.03 to the fifth power. Let me clean that up a little bit. 1.03. Whoops. 1.03 to the fifth power. So the real value will be equal to $4,373.94. So this investment, if we think about what it's going to be worth in the future, and we want to base it on today's value. So we take this thing, it goes into the future. We know that we're going to get this interest. Because the bank has told us, okay, if you put this in, you're going to get this interest back. This is what you will have at the end of the year or at the end of the 5 years, right? So I put it in there, nothing changes. But while it's sitting in the bank, inflation is happening. So I need to think about, all right, I can't really think about what my money is going to be worth in the future, so I need to think about what it's going to be worth right now. So I know that this is going to happen. This is what I'm going to get, right? But if I've got an inflation rate that's going at 3%, then what is this thing worth right now today? Well, that's worth $4,373. So in today's dollars, this 4,000 5 years from now, calculated with this, is really only worth this much. It's not actually worth this much. And it's kind of a weird thing to think about. How do you have the different values of these dollars? But again, like, sometimes people say, if something costs something today, is that same cost is it going to be the same thing? Is your money going to be worth the same amount in the future? And so that's what this real value is trying to tell you, so you can compare it to what you're buying today. So $5,070 5 years from now is worth $4,373 today. That's essentially what we've just done here. And actually, let me write that down. So in a nutshell, $5,070.60 in future value is worth $4,373.94 today. That's essentially what we just did. Okay, so that's what's happening with this calculation. All right, so here we go. We're going to do some depreciation. So now we're going to look to see what happens when something goes down in value, and then we're going to find out what it's worth. So this will happen as you get older and you start buying things like refrigerators and washing machines and dryers and all this kind of stuff. It's going to cost money, and then at some point you might move and you want to sell it, but it's going to go down in value by wear and tear, by you using it, by just the cost of it, by inflation. Everything is worth less as you go on. So maybe this is a company. It's an industrial dishwasher. They're purchasing this dishwasher for 2,400 pounds, and it's depreciating by this amount, by 15% each year. So what is this thing worth after 6 years, and how much did it depreciate? Well, this should be pretty straightforward. This will probably be the tricky one. So we know we want to find out what this thing is worth in 6 years. So we want to know, let's make a little space here. Let's get rid of this. So we want to know what is it when n is equal to 6 years. Now, inflation or depreciation usually is only calculated every year, so you don't have to do like a whole big adjustment. And we're going to have our u of 0. Our u of 0 is equal to 2,400, so that's what we're originally paying. And then the depreciation value, how much it's depreciated by, is 15%. So that means this is taking off minus 15% each year, right? That's what depreciation means. So if I want to know what the value is, I don't want to know how much I'm taking off. If I want to know the value, I want to know what it's worth. So to find this depreciated value, I can do 1 minus 0.15. So that's basically me saying 100% of the value, 100% of the value minus 15% equals, so this is the original value. Let's say that 100% of the original value minus 15% depreciation is equal to 85% value now, right? So that's why we're subtracting this 1.5. So our value that our interest that we're going to multiply this by or take away from here is not going to be 1.015. It's actually going to be 0.85. That's what we're going to be multiplying this by. So now when we calculate this whole thing, we've got u of, oops, oh my goodness, everything popping up here. We've got u of 6 is equal to 2,400 times our depreciated our depreciated rate, which is 0.85. So notice this is saying this is going to be less now, right? Because we don't have the 1 in here. That means this thing is going to go down. And we're going to do that for 6 years. So that's going to be to the 6th power. So when we calculate that out, we've got 905, what are we, pounds, dollars, pounds, 905 pounds, 16 pence is what that is. So there's our value for today. Or in 6 years. So how much did it depreciate by? B? Well, again, that should be fairly straightforward when we think about that. If its original was 2,400 and now or in 6 years, it's worth 905.16. Okay, let's put our 0. If we subtract these things, okay, well, we subtract those, then we're going to end up with our how much the depreciated value was, or how much it depreciated by, which is, let's see, did I do a symbol? There's the symbol. 1,494 pounds, 84 pence is the depreciated value, or the depreciation. Depreciation, I think is how we say it or spell it. So that's our depreciated value. Wow. Okay, so I'm going to stop there. The next section would be technology, and that's going to be better to be talked about on another video, but I'm going to stop here. This gets you through the vast majority of the financial math section. So thank you for listening.